within the soil, there's not much nutrient holding capability in those sands. All that sand is really broken up rock. Sand is just fragmented rock. Well, what nutritive value is in a rock? Well, not a whole lot. In fact, about nothing. It's all the stuff in between there, the organic material that is filling in around there, that is going to give you the value for nutrition for the plant. That ground up rock is simply a stability base for all this other stuff to end up in there. The organic material is going to become the nutrition for the plant. And there's a little guy called a colloid. Very fine organic material, size of that would fit in the clay category. And soil is a combination of organic and inorganic. Well, the colloids are the organic clay parts that do have the nutrients and also will attract nutrients as we apply nutrients to the soil in the form of fertilizers, and we'll hold on to them. Then the colloids are basically the smallest particles within the soil, and they are the nutrient holding little critters in there that are going to give us nutrition to the plants. So the plants are going to take their nutrition from those little colloids. They're not going to get any nutrition from the sand particles. Isn't going to happen. No nutrition there. But the little colloids that are stuck in amongst the sand particles will have the nutrition with them. That's why when we make those sand greens, we blend in organic material. And then as time goes by, those chunks of organic material break down into smaller and smaller pieces due to the aging process, bacterial breakdown, and mainly is going to be the cause for them to break into smaller and smaller fragments and break out their nutrition to make them available to the plant itself, and then the plant sucks that nutrition out of the colloid and into its root and up into the plant. And where does all this stuff come from? Well, the rock obviously has been placed there by the formation of the earth, and then as that rock deteriorates, there's a couple things that cause the rock to deteriorate. One is weathering, and the two types of weathering that occur are going to be the freeze-thaw effect and then also precipitation. And so as you get freezing and thawing, you get the rock to crack and fracture and get water in there, and it freezes and thaws, creates more fracturing. You get then transporting that stuff. We can transport those as the pieces get smaller and smaller. If it's through precipitation, they will flow downstream, down the side of the mountain, down the stream, deposit alluvially in floods and the like. Or we can have winds pick them up and blow them sideways across the terrain. And we've all been through a nice windstorm, and we've all seen one of those brownouts in this country. We get them a lot in eastern Washington in the springtime, where we might have some tilled fields that dry out, and then a big windstorm will come up and we'll get a serious dust storm out of it, and we'll move quite a few tons of dirt around soil around the area. Or we can have floods, and we've seen floods in the last few years around here that have moved a lot of material down, and you can really tell. Just go down to Wallula and look at the giant mud delta that has been formed by the Walla Walla River where it enters the Columbia. That's all transported soil by flooding that has moved all of that soil downstream, and then it's settled out in that Walla Walla River Delta where it hits the Columbia. Yeah, it's a great bird habitat, but it's all ground that has left the field or the forest, and you know, we hate to lose that topsoil because it's usually topsoil that we're losing.
And then you get volcanic ash too. Yeah,
and then we had Mount St. Helens blow up in '83, and certain parts of the state, it put down a couple of 1980, put down a couple of 3 inches of ash in places. And you know that ash size is different too. Closer to the mountain, the particles were bigger. Further away you get out to Spokane, you know, the particles were a whole lot smaller by the time you got to Spokane, because the smaller particles drifted further in the air. The bigger chunks fell out a lot sooner. So the much bigger particles closer to the mountain. Further away from the mountain, the particles were much smaller. So we even had a striation of particle size in the ash from Mount St. Helens over its dispersal area. So there again is another way that it happens.